This is 2G question 4, part B. So it bisects the angle, also that the normal at P bisects angle APB. APB. So this is the normal. If I extend this, this is the normal. So that's the normal, and it bisects. So in other words, we have to show that theta has equal to phi. Okay, we have to prove that the normal at P bisects angle APB. So we have to show that theta equals to phi. Where do we begin? Okay, so if we say, let's consider where the normal cuts the x-axis. This is the x-axis. This is what we call the y-axis. And it cuts the x-axis. Let's call it at the point with, say, capital X, doesn't matter. And it cuts it there. How do we work out where the normal cuts the x-axis? Well, first of all, can we find the equation for normal? Okay, so if we say, rearranging it, we can, if we say dy by dx is what we're looking for the equation of the tangent, or rather the gradient of the tangent to the curve. So that's what I'm looking for. What is dy by dx? Okay. Well, I can do this implicitly, can't I? I can say, if I differentiate implicitly, that 18x plus 50, in fact, no, there's a plus 50y dy dx is equal to 0. Is that right? So dy by dx is equal to minus 9 over 25 minus 9x over 25y. Is that right? Okay. Now, how would we do this parametrically? We found dy by dx in terms of x and y. How would I do this parametrically? What is the, so we know this is an ellipse, and what is the equation of ellipse given parametrically? Now in this case, what is A and B? Three. So what is the gradient of the tangent? And so the gradient of the normal, let's call it Mn, is equal to the negative reciprocal, which is 5 sine t over 3 cos t. Does that make sense? And at any point t, p on the curve, we can say that the equation of the normal is y minus 3 sine t is equal to the gradient of the normal, 5 sine t over 3 cos t, x minus 5 cos t. So now we have the equation of the normal to the curve at the point P. Okay, so when y is 0, you can say that minus 3 sine t is equal to 5 over 3 cos t. Let me just write that in. Minus 3 sine t is equal to 5 sine t over 3 cos t, x minus 5 cos t. I divide through by sine t. Cos t. Cos t. Okay, so about the bad handwriting. What can I say? Is that minus 9 cos t is equal to x minus 9 over 5 cos t is equal to x minus 5 cos t, just to rearrange it. Okay. Okay, so I can say that x is equal to, just rearranging that, simplifying the fraction, it's 16 over 5 cos t. All right, good. What I'm now going to do is call this angle alpha. Okay, then these angles are complementary. In other words, they add up to 180. We should know that. Angles in a straight line add up to 180. And therefore, this is 180 minus alpha. Okay, so we know that. And now let's just think strictly geometrically for now. Yeah. So let's have a think geometrically. So if we consider what sine theta has to be, let's have a look at that. Sine theta, let's use the sine rule. Sine theta over this distance here, a to x. What is that distance? How do I work out that distance? X plus 4 has to equal to, let's call it PA, all over, sorry, wrong way around, sine of 180 minus alpha all over PA. Is that correct? Let me just put in the coordinates of P. So P has coordinates A cos t, so it's 5 cos t and 3 sine t. That's the coordinates of P. Can you work out what PA would be? Well, what we could do is simply use Pythagoras' theorem to work out PA. So let me just do that. I can say that PA squared is equal to, well, the distance there, that is the x coordinate of P, which is 5 cos t. So is it 5 cos t plus 4? Is that the x coordinate? The distance between x and a, is that right? Squared plus the y coordinate squared, which is 9 sine squared t, is it not? If I now expand this, get 25 cos squared t plus 40 cos t plus 9 sine squared t. Now here's a little trick in these situations. I do not want PA squared, I want to look for PA. So let's see if I can factor something out. I've got here sine squared and I've got here cos squared. If I can make it all in terms of cos. Okay, but the key here, I can split up the cos squared. And of course, we've got here the plus 16. Now, can I split up this cos squared? Actually, that's the right suggestion. So 16 cos squared. So I split that up as 16 cos squared t plus 9 cos squared t. Can I do that? Is that the same thing as 25? 16 plus 9? Yeah. Plus 40 cos t plus 16. Is that right? What can I do with the 9 cos squared t and plus the 9 sine squared t? What can I do with the 9 sine squared t and 9 cos squared t? what does that become? That equals to 9. Okay, so this simplifies to, so we can see you get 16 cos squared t plus 40 cos t, and you've got the 9, so you've got the 16 here still, and you've got the 9 because these two terms just become 9 plus the 16, so you've got plus 25. Is that right? I've written the 16 out twice. Yeah. Is that right? Okay, and then the last part, so we can factorize this as 4 cos t plus 5 all squared. And PA is equal to 4 cos t plus 5. Is that right? Yeah? What is PB? And we know from part A that PA plus PB has to equal to 10. So PB is equal to 5 minus 4 cos t. So we now sub in, just a side note, we know that sine of 180 minus alpha is the same as sine of alpha. Is that right? So let's just rearrange it and make sine theta the subject. So we've got sine theta is equal to x plus 4 times sine alpha all over PA times that by x plus 4. Okay, so now let us combine the fraction. If I times this one by 5, I get 16 cos t plus 20 all over 5. I now rewrite that, and here that is sine alpha over 5 4 cos t plus 5. Now this expression, if I factor out 4, I get 4 cos t plus 5, don't I? And I can see here that cancels with that. So I'm left with 4/5 sine alpha, which is equal to 4/5 sine alpha. All that remains is for us to show that sine of phi, using exactly the same method, will also give us 4/5 sine alpha. So from part A, we've now shown that that is 4/5 sine alpha. If we can show that sine phi, let me just write that again. We've shown that sine theta is equal to 4/5 sine alpha. Now we're going to do the same thing for phi. Let's do that now. Again, if I use the sine rule, I can say that sine phi over this distance, which is now 4 minus x, is equal to sine alpha all over PB. But we have that PB is 5 minus 4 cos t from the previous question. So let's just now solve this for sine phi. Okay, so I can say that sine phi is equal to sine alpha over PB 5 minus 4 cos t times 4 minus x. 4 minus 16 over 5 cos t. Now, if you do the algebra and simplify, you get 4/5 sine alpha. Now, we have therefore shown that sine theta is equal to sine phi, and since they both are part of a triangle, they both must be acute, and therefore theta must equal to phi. Okay, so we can now conclude, therefore, since sine theta equals sine phi, theta is equal to phi.